All right. So this webinar today is going to cover the cloud, and we're going to cover cloud security. Now, we gave this presentation a very interesting name. We called it "How Can Cloud Be Hacked?" Right? We're essentially going to say, yeah, that's what we're going to be talking about, but we're going to also talk about real-world use cases of cloud hacks, right? So essentially, we're going to look at how cloud security works, right? What vectors of attack exist within cloud security. We're going to look at what kind of issues you could come up whenever you have cloud security in mind, and how it just compares to general security practices that we do in IT. We're going to look at attack vectors. So the attack vectors are essentially ways of an attacker to come in and attack our environment, right? Attacks can vary from just pure script kiddies running scripts and, you know, trying to see what they do, to attackers trying to deny our services, trying to overwhelm our applications, to attackers actually intent on breaching information or getting into our environment and misusing our services themselves. Then we're going to look at some attack examples. We're going to look at what kind of typical attack examples exist out there. So we got 6 different attacks that we are going to take a look at. Then we're going to look at how to secure our applications. And finally, we're going to end this day with a Q&A where we're going to talk about what kind of questions you have, where we can discuss any real world case scenarios that you want to talk about. All right. So the overview of cloud security, essentially we start with a security lifecycle. Any implementation of any application, whether it's on-site or is in the cloud, should follow your standard security lifecycle, right? Your starting point is on top. You have the categorization of your IT environment that you have to do, right? You look at your systems, you look at where possible security threats could come from, you look at all the entry points and you document those, right? So for each of those categories that you sort of apply a server or a service or an environment to, you will select some security controls. So in the select security control stage, what you're going to look at is what kind of features can be used to secure that environment, right? Am I putting a firewall in front of it? Am I encrypting the data? Am I making sure that I'm tracking what my users do? Once I've got selected security controls for each of those features, I implement those security controls, right? That essentially says I'm configuring the rules, I'm configuring the policies, I'm making sure that I encrypt the data. And then once I have done those, I assess, right? Assessment is a crucial part of security because you need to have a good idea of whether those security controls actually work. That's where a lot of security fails on, where somebody implements a policy and they never assess that policy fully, right? They test it if it works, but they don't test how they can misuse that policy. And that is the idea of security that we have to have in mind. We always have to think of ways of how can we try and breach this security control that we put in place. Once we've assessed them, we authorize the security controls that work and put them in production, right? So those that are put in production then need to be continuously monitored. And if we find any issues with those security controls, if we find any vulnerabilities in our security tools, if we find any kind of exploit, any kind of attack vector that is new or that could expose our data or breach our security controls, then of course we need to feed that information as soon as possible back into the categorization step so that we continue in a cyclical manner to continuously improve our security controls. You can see that this security lifecycle can fairly easily tie into any modern development practices, right? So whether you're doing things like feature-driven development or whether you're doing things like test-driven development, you're doing CI/CD, you're being agile, etc. The security lifecycle that's been in use for years, probably for decades, is going to fit very well into those features. And we'll also talk about that at the end of this chapter. So the security layers in a typical environment, first and foremost, the most important security layer of all is the user access, right? This one has the most unknowns. We need to make sure that we allow users to access data, but that we also monitor and assess whether those users are accessing the right data at the right time, or if this looks like a certain type of exploit, a certain type of attack. We also need to ensure that we educate our users on attack vectors, right? It's not just putting the controls in place, it's making sure that users do use those controls and that the users understand how much of a risk they pose to the business itself, right? If we just mention phishing attacks here, user access is basically what phishing goes for, right? They try to convince the users to give them their password, their PIN, their MFA, serial number, and things like that, right? So what we want to do is we want to make sure that we implement user access correctly, and then also educate users on the requirements, on the needs of using the user access correctly. Next, we need to protect our data. And that takes two sort of different approaches, right? First, the data needs to be resilient. If I lose the data, if I have any kind of issue in my data center, I need to have a copy of that data so that I can survive any kind of hardware issue, any kind of software issue, any kind of misconfiguration, any kind of injection of improper data, right? That can also be due to an attacker, right? An attacker can come in and they can, delete our database. If I have a backup of that database that is done in an efficient manner and can be promptly restored, then I'm sort of doing half of all the required data security. And the other half is encryption. Now, encryption used to be an expensive thing to do in your IT because it would take a lot of CPU power to do encryption. Modern CPUs have hardware accelerated encryption, at least for the most commonly used encryption standard like AES-256, or maybe for HTTPS for TLS. Those features allow us to essentially integrate encryption into our application without the overhead, without the cost of the CPU power that used to be a factor in these operations. And encryption should be looked at with two approaches, right? First, we need to look at encryption in transit, right? We need to make sure that we encrypt our data between our environment and any user coming into that environment. We also want to make sure that we encrypt our data once it is on our environment so that if any kind of breach happens, only encrypted data will be able to be stolen from that breach, right? So we need to make sure that when we do encrypt, we encrypt in a way that makes use of services that will help encrypt as transparently and as efficiently as possible. Now, depending on the application, whether it's a database, a message queue, a web server, right? These encryption standards will be different. These encryption tools will be different. And we need to select the right type of encryption tool and the right type of encryption service for the right type of data. We can follow the same principles that we did when we were assessing security to also choose encryption standards and encryption mechanisms and services for each of our application components. Once we got these two out of the way, right, users using our environment securely and our data, especially sensitive data, being encrypted, then we need to look at the platforms and the applications that we're running. So any database services, any message queues, any DNS, any services that are installed on any operating system, we need to make sure that those do not cause a risk, cause a um, possibility of a breach, right? We have famous cases right now out there where, huge breaches of personal information were stolen due to a platform that was unpatched, right? So patching your platforms, patching your applications is a crucial aspect of security. Possibly the most important aspect of security is patching. Because without patching, if you get a remote security vulnerability, you're essentially opening up your services to anyone, right? You're opening the door, inviting anyone to come in and say, hey, what do you want to do with my data? Here you go. The next level is the operating system. Again, for the operating system, patching applies in the same way, right? There's security holes in the operating system. And of course, what we can do in the operating system, we can enable the operating system firewall. We can install agents that check our services. We can lock down the operating system, right? We can use things like namespaces inside of Linux environment where we close the operating system down for a certain service so that only that service exists in there. Then we can do pattern analysis on both the network traffic and the CPU traffic inside of the operating system to look for any signs of vulnerabilities, to look for any signs of exploits. We can do IPS, IDS agents inside of the operating system. So there's plenty of things that we can do inside of the operating system to secure it. The next layer is whatever is allowing us access to the operating system, and that's going to be the virtual network. So the virtual network, with most providers, you have the ability in the cloud to actually implement their firewall solution for free, right? Most cloud software will give you the ability to create security groups, to create the network policies that allow certain types of traffic inside to your network and into each instance that you have. So it is a very, very crucial part that you also implement the virtual network security so that essentially you're only allowing the right types of traffic to come into your environment. On top of basic network security like port-based firewall access, port-based network security rules, we can also add features like denial of service protection, IPS, IDS services, virtual firewall instances, next generation firewalls, web application firewalls, etc., in front of our application, right? This is going to be determined on a case-by-case basis. It's going to depend on whether you use an operating system or whether you use a service in the cloud. But still, that's also part of the protection of your virtual network. Now, the next two layers are the hypervisor and physical security. Usually in our own data centers, we would need to make sure that we secure those, but when we're in the cloud, those will always be secured by the provider, right? So the provider essentially needs to take care of the security of the hypervisor and the physical security, and needs to have a way to track what they're doing inside of that environment, right? So what the provider usually does is they do like very, very stringent change management. They do compliance testing with different compliance standards, and they make sure they have reports from all the compliance standards, from all the assessment tools available to all the customers, so that when you're checking your compliance, you know that those underlying layers have been secured to a certain degree. And that's what we call a shared responsibility in the cloud, right? Because you are using services that were delivered by another vendor, the cloud service provider is responsible for some parts of the services. Now, generally, we split up cloud services into three different layers. With the infrastructure as a service, where we just buy virtual machines, we buy networks, we buy storage, right? Raw components. And those raw components we then build into our application. The next layer is platform as a service, where the cloud provider actually exposes a platform like a database or a message queue or a DNS service to our account. And then we can just configure those with our data, with our configuration, with whatever we want to do. We use that platform service. And then we've got software as a service. This is just a component that we buy online. So your Gmail account, your Office 365, all of those are examples of software as a service, right? With cloud shared responsibility, whenever it comes to any of those layers, you still have to be responsible for your people and your data. You always make sure that you control access on your own. You have to set up the appropriate security controls and educate your personnel, right? Then you have to take care of your data. Make sure it is accessible only to the right people and make sure it is encrypted if required. When we're talking about platform as a service, we add an application layer to our responsibility and the rest is handled by the provider, right? Because we're just using a database, we're probably going to deploy an application on top of that that will access that database. So we need to also secure the application. We need to also patch the application. We need to make sure that everything is working. The platform and the operating system and the virtual networks are taken care of by the provider when we're looking at platform as a service. And with infrastructure as a service, now this one gives you the most flexibility, but also requires the most knowledge of all these broad IT concepts, right? You have to secure whatever you secured in platform as a service, then you need to secure your operating systems, then you need to make your virtual networks resilient, then you need to make sure that you put stuff like firewalls, IPS, IDS devices in front of your network and run the architecture through the cloud, which can become fairly complicated. So essentially, when we're looking at software as a service, this is the least management solution. You're the least responsible for the services themselves. You just use the service, but you still secure your data and your people, whereas the infrastructure as a service gives you the most flexibility, but requires the most knowledge and can get fairly complicated. All right. So now let's look at attack vectors. So what kind of attack vectors do attackers come through, right? So with cloud, there are two ways to access our application. There's the user access where all our clients or our customers, all our users will be accessing the application. So this is a web front end. This is a, an email client, any kind of thing client. This is anything that we want to choose to access the application. And then there's the other vector of attack, which is the side channel, which is attacking our applications through the cloud account, right? So in the side channel attack, the user, the attacker, will convince a user to somehow give them the credentials. Now, phishing is the most common way of doing that, but sometimes those credentials are stolen by personnel internally. There's a famous case in the UK of a disgruntled administrator that actually just got 3 years in prison for his actions. He wasn't happy about being let go. He stole his colleagues' credentials and he went into the company's cloud account and severely affected 35 different applications. The company estimated they had a loss of about 500,000 British pounds. But since they did not implement all the security controls available in the cloud, the judge ruled there that he is not responsible for the damages, although he is criminally responsible for accessing a computer system without authorization. So he only got 3 years, but didn't have to pay anything. So it's a sort of win-win, lose-lose situation in this case, right? There are controls to prevent side channel attacks, right? First and most common control is multi-factor or two-factor authentication. With those, what you can implement is your username, your password, and then a second step of authentication, which is either a soft or a hardware token or some kind of a USB stick that has a chip on it that will help be the second step of authentication, right? The other way is when users do gain access, make sure you audit actions that are taken by users. Make sure you have an ability for the users to elevate their privileges, just like sudo in your Linux operating system, where you elevate your privileges to an administrative level, right? You have to have the same types of controls inside of your cloud account. Different providers doing it differently. So, it will be up to your provider, but all providers offer you that option. Next vector of attack is denial of service or distributed denial of service. Now, DDoS or DOS attacks basically mean that our application is sitting out there on the internet and an attacker is trying to take it down by sending a lot of volume or sending an attack type that will essentially make our application not be able to respond to valid requests. There are several ways to protect from this. So DOS or DDoS attacks, basically, you can protect from those by implementing the right type of DDoS, DOS protection. There are services out there and there are platforms that can offer that type of protection. Whenever you are using platform as a service, the cloud provider usually will implement DDoS or DOS protection at their service layer. Think about it. When you're using a platform, you're using a service from a provider that, possibly hundreds of thousands or, millions of other users are using at the same time. So an attack against you, a DDoS attack against you is an attack against all the cloud provider clients. So the cloud provider inherently will provide the DDoS resilience to all of their services to make sure that their services are available to valid clients and they filter the DDoS attacks by themselves. Of course, when you're using infrastructure as a service and you're building it all on your own, not using a service, you have to think of DDoS and DOS as a possible vector of attack. Next, injection attacks. So what injection attacks do, they essentially add hidden input to our URLs, to our command inputs, right? And that hidden input can contain executable, can contain some kind of code that will allow the attacker to inject their own function into our service, right? Injection attacks essentially come in a lot of different ways, and injection attacks are fairly easy to defend from. But we have to understand our application in the utmost detail. We have to know what the regular and allowed patterns in our application are to prevent from injection attacks. If we know what we are able to receive and respond, then any injection attack can be simply filtered out by a web application filter or a next generation firewall. Next, vulnerabilities. Any vulnerability is a vector of attack, right? It's not essentially a vector of an active vector attack. It's a passive vector of attack. We don't know that the vulnerability is there. We don't know that the attacker is going to use it. But if it is there, and there is a possibility of the attacker using that vulnerability, we're leaving our backdoor open, right? We're leaving our door to the house open, and we're just wondering, well, maybe somebody will walk in or maybe they won't, right? There's that is synonymous with not patching right now out there, and it's Equifax, right? So basically what happened in Equifax, they forgot to patch some Apache framework. Well, they let it go for 1 month, and then in the next month's patches, because it was sort of put to the side, nobody figured to patch that, right? And had they patched it within about a month or so of the vulnerability being disclosed, they wouldn't have had a problem. But because they're a big company, a month is a long time. And within a month, the attackers were inside. They managed to transfer terabytes of data out of Equifax. They managed to steal about 100 million US citizens' information, their social security numbers, their private information like driver's licenses, addresses, credit card numbers, whatnot, right? Also, about 2 million Canadian individuals were affected, since Equifax does credit rating services in both of these areas, as well as about 100,000 individuals in the UK. So pretty bad result for that exploit. There is a $1 trillion lawsuit out there against Equifax by a class of victims of the attacks. And of course, when we talk about personal information like social security numbers, if somebody steals your password, you can go and change that. If somebody steals your social security number, yeah, good luck. Call up the government and tell them, yeah, somebody stole my SSN. Can I get a new one? And they'll be like, no. The SSN was never meant to be a credential, right? So the way it's issued and the way it's used and the way it's misused now is improper. It was never meant to be a password. It was never meant to be a credential. It was only meant to be an identifier for a user within the tax system, right? So that's essentially what needs to be done here is, you know, SSN, SIN, these kind of systems need to be re-implemented. Next, loose firewall and access policies. Here, a great vector of attack where we open a firewall because we're testing and then we forget that, or an administrator is struggling with a firewall, they open it up and it works and they leave it there, right? Always write your firewall policies to the relevant targets, to the relevant clients that are accessing the environment, to the relevant regions. If you don't have any clients outside of the US, why allow access from other countries at all, right? Access policies are even more crucial, right? You might have a vulnerability inside of an environment, and then on that environment, you might have an access policy that is open to all internal resources, and suddenly an attacker gaining access to your, you know, insignificant device can access all other storage environments inside of the account. So that's what happened with Credit One just recently. They had an attacker who used to be an engineer for AWS, actually, so they knew their way around the cloud environment. The attacker actually went into an unrelated system, but then on that unrelated system, it was a web application firewall. They found that that web application firewall had a policy that allowed it to read and write to and from every S3 bucket inside of the environment, every storage area. So it was designed to write logs to one specific bucket, but whoever wrote the policy just put a star in there, right? And essentially allowed the attacker gaining access to an insignificant system to gain access to, again, over 100 million clients of Credit One, right? So basically, pretty much every client of Credit One was included in the attack. Some clients actually had their, you know, very, very stringently held information like their account numbers and the amounts of money in their accounts and their personal information, credit card numbers exposed. Luckily, that attack was contained pretty quickly because the attacker's motives are fairly unclear. They attacked and then told everybody they attacked the environment on GitHub, which is very unusual for an attacker with malicious purposes. It seems more of a, you know, mental instability than maliciousness in this case. But still, a hack is a hack, and we have to protect from such hacks also. Next, lack of encryption and backups. You can have your data stored securely, but if it's not encrypted, it's not secure, right? So any kind of data, as we said, needs to be encrypted so that if an attack does happen, if there is a third-party environment that gets exposed, that data is not unencrypted and accessible to everyone. And of course, backups in case we lose our data. Here we also have to mention phishing again, because general phishing to get access to the application, to get access to the operating system, to get access to any kind of user data is, of course, key to our security, right? Make sure you educate your user, make sure that everybody is prepared for phishing and understands what phishing is, and understand that nobody is going to ask you for your password over an unencrypted connection like email, right? We all know that. All right, types of attackers. First, script kiddies. Every day, all the time, these are out there. Vulnerabilities are usually being open sourced, right? And also any kind of attack tools are available on the internet. Script kiddies are basically individuals trying out scripts, seeing how they can gain access, seeing how they can exploit a vulnerability. Now, script kiddies some of them will grow up into lone wolves. Now, lone wolves are attackers that actually do this kind of stuff for, for profit. Basically, we should call them the self-employed hacker, right? The self-employed extortionist, right? So basically what they do is they find an encryption tool or something like that. They use an exploit, a script. They push that encryption tool onto an unsuspecting victim, and then they want a few $100s from that victim, or even in the tens of thousands of dollars when it comes to hospitals and municipalities that have been recently attacked. Then we've got advanced persistent threats. Now, advanced persistent threats are groups of individuals, whether they're, based in different countries. We know about the different groups of servers that they use. We know about their capabilities. Some of them have servers in the tens of thousands that they control. Some of them have huge botnets of devices like IoTs, etc. Now, advanced persistent threats are categorized by the security companies, and you can get information about advanced persistent threats and add those to your firewall policies. Just don't allow access from anything that is known as an advanced persistent threat, right? And advanced persistent threats, they're financed by crime. They're financed by essentially some foreign governments. They're essentially financed by individuals with a lot of might, and those are groups of hackers that are very, very hard to stop, but are well known. So essentially there is a way of stopping them also. All right, we have two questions. Do backups still need to be on a cloud environment as the data is replicated? Yes, you still need backup, Gerald. Backup is crucial. Why do you want to have backup? You want to have backup because a user might make a mistake, and that mistake is going to get replicated across the environment. Somebody deletes your database, and that will still get replicated across your environment. A backup is a point-in-time copy that you can return to in case your data gets corrupted, right? The replication in cloud is replication. If a corruption comes in through a legal sort of access point, like, for example, a user sends in a corruption, that corruption will be replicated across the environment. The replication in cloud allows us to survive any failures in the cloud, like 1-bit errors on disk drives, right? These are so common. 1-bit errors on disk drives, if you don't have multiple replicas to check the replicas against each other, you cannot fix a 1-bit error very easily, right? So things like that. And Gerald, yes, it's not just for archiving purposes. Backups, although they lead into archives, you can still do archives. You can have rolling backups, like you can have 2 weeks of daily backups just in case something goes horribly wrong, right? So they are still required in cloud. Now, how do you do cloud backups? Well, what you do now essentially is you quiet your application, and then you create a snapshot of that environment, that volume, that instance, whatever you're using to store that data, right? You can also copy data over to another region. You can copy information over to another region, etc., right? But replication is synchronous. So when a corruption comes in, it will synchronously be replicated across the environment. Even if it is asynchronous, it will leave you just, a few minutes to react, or maybe an hour to react. You cannot protect from that without a clear, good old-fashioned, another copy of your data. As we say in the industry, if your data is not stored in 3 places at once, then it does not exist, right? All right, next we've got industrial espionage. Espionage is a big problem. Sometimes it is also crime-related, also related to other government powers, but most of it actually is happening within the industry, and the industry does employ a lot of experts, a lot of security experts that you know, are not necessarily the most not necessarily operating in the most of the legal ways to try to gain access to other services of their competitors. And then finally, internal breaches. This is the attack vector that is the most easy to exploit and the most difficult to prevent from, right? Internal breaches essentially mean phishing, mean disgruntled employees, mean any kind of employee that takes your data and carries it over somewhere else, right? We've seen internal breaches stem from employees trying to steal data for personal gain, employees taking their company data to other companies, employees being disgruntled, employees being phished or hacked, and then internal breaches do happen. All right, so let's look at some attack examples. First attack example is a typical DDoS. It's a UDP reflection attack, right? UDP is a stateless protocol, so essentially when you're sending a UDP packet, there is no session, there is no state maintained, right? Whatever you put into that packet is going to be received as, yeah, that I trust that that's it. So it is easy to spoof a certain IP address. So what an attacker will do is they will spoof an IP address of the victim, right? So here the victim has the IP address of 45.31.123.12. Now what the attacker does is he creates large packets, for example, 64K or 128K packets, and sends requests with those packets, with the message that is that size to a certain server that has a vulnerability, a DNS, UDP reflection vulnerability. Now, that server will automatically start responding with 4K responses to the victim, right? So for each part of the 64K request, it will return, what is it, like, yeah, it's 15 times more data, right? So essentially, if you have one bot sending a request to a server, it's going to return 15 responses, 15 packets back to the target, right? If you have 10 of them, it's going to be 150 packets, right? So basically what you're doing is the reflection amplifies the amount of packets that are being sent to the target with the more attackers that you have, right? And essentially the attacker is trying to find a server that's vulnerable and is also going to be responding to those UDP requests. Now, this attack is not as common anymore because a lot of providers, a lot of firewalls have made it easy to block this. Operating systems have made it simple to mitigate this, right? But what we need to know is that this is still a valid attack and it still exists out there. So another attack is a SYN flood, right? So a SYN flood, essentially, we've got a another way of attacking. This time it's through TCP ports, right? And because a lot of systems have just started blocking UDP because it's not used very commonly, and just allowed TCP, attackers switch to TCP SYN floods, right? It's also a network layer 4 attack, right? So essentially what it uses is the TCP synchronization packet where it sends a synchronized request with a spoofed IP address, right? And of course, the target will then respond to that synchronization request to a non-existent spoofed IP, right? So that screen with the X right there, that's an attacker, that's a system that doesn't exist because we spoofed that IP. So if any legitimate users come in, we try to use up all the sockets and hold the connection open until the synchronized request times out. And synchronized requests have been set to, you know, very high numbers. Sometimes it's even minutes before the synchronized request expires. So it's easy to overwhelm a server with an attack like this. Then we've got a DNS flood. Now, a DNS flood, essentially an attacker will use a bunch of nodes that they expose to try and attack a DNS system, right? The DNS will look for any non-existent records. So usually the botnet queries from non-existent subdomains for non-existent records, right? So it essentially is designed to overwhelm a DNS service. Now here, DNS uses UDP on port 53 to talk. So it's a pretty much a variation of the UDP reflection attack, right? Except we're trying to do it with a valid service, with valid DNS requests. If you're using a managed DNS service at a cloud provider, you don't need to worry about those at all. If you're using your own DNS, then of course you have to. On another layer 7, of course, we want to attack the machines, not the DNS service, right? If somebody uses a managed DNS service, then, you know, DNS floods just won't work. So we want to attack the machine. So SLOWLORIES is another type of attack. So what we do is, in a typical HTTP response, we send the packets for access, and then the server responds with that access, right? We send a request for an index web page, and then the server responds. But if an attacker does it, what they'll do is they'll split up the request into packets, and then they'll send the first packet, and then 10 minutes later, they'll send the second packet, and then 10 minutes later, they'll send the third packet, and then 10 minutes later, they'll send the fourth packet, right? Keeping the connection open. And if this is a botnet and all the bots are doing SLOWLORIES, right, they'll consume all our ports. Our server will wait for their responses. The server's CPU will be very low. Auto-scaling will not kick in because server CPU consumption will not rise, but the website will not be responding, right? So a typical SLOWLORIES attack is a very intelligent way of making sure that you can take down a web server. Now, also, it's easy to protect from, because what we can do is, if we don't receive a request in a certain number of seconds, in a certain number of milliseconds, if the complete request is not finished, then we just drop that packet. Now, we have to take into account any mobile clients, any clients in slow connections that will actually be sending these packets in a very, very slow manner, right? So we need to find a right balance of what is a SLOWLORIES attack and what is a user on a slow backend or very far away. Next, remote execution or backdoor, right? So basically with remote execution or backdoor, we've got a vulnerable server. We've got something that we didn't patch, right? So basically the attacker will send a valid HTTP request, but target the vulnerability. And what they can do is they can drop in code in that HTTP request, and in the backend, a remote access tool can be installed. And then the remote access tool actually calls the attacker back, right? So it's not the attacker trying to get into the remote access environment, into your SSH or RDP. It's actually the remote access tool that will use ports, any port that is open on the firewall, like for example, return ports, random return ports that come from the vulnerable server. It will use that port, it will connect to the attacker, and it will open a connection and let the attacker in. Once the attacker is in, you know, that's a whole other story. And then loose access policy. Like we said, what happened with credit one, right? So basically, attacker sends a valid request that is targeting private data, right? So if a valid user will be sending a request for public data, and of course the public data will be returned. But because there's a loose access policy on the server itself, right, and allows access to all backends, an attacker can send a request, smartly targets private data, and then finds that private data, and the server will return private data because it has access, because the policy is just allowing it to do so, right? So always make sure your policies are need-based. Whatever I need to specifically do, that's what I have to implement. And then, of course, last but not least, internal breaches, right? We, as the admin, we're giving keys to our house to our users. How do we figure out whether this user is an attacker or this user is a very valid user, right? Is it the devil or the angel? Well, the only way to do that is to continuously monitor, to implement escalation of privileges to add multi-factor, two-factor authentication on our application, on our accounts, into our operating systems, so that we have a way of checking whether the attackers are valid or whether the attackers have received some credentials or trying to use them, right? Access to our accounts needs to be strictly monitored, and any action on our account that seems inappropriate needs to be identified. All right, Ricardo, we have a question from you. So, is there a way to identify if we are under attack or have a resources issue? Yes, there definitely are many ways to do that, right? The first thing is take a look at your logs, right? Your web access logs. So, for example, in a SLOWLORIES attack, here you're not sure whether it's a resource or it's an attack. In your web log, you will see the requests coming in from a certain target or a certain group of targets. What the attackers usually do when they breach a certain network, they will come in from a fairly like similar range of IP addresses, etc. Right? And we can check through the logs and find patterns in the logs that indicate that this is a SLOWLORIES attack. Right? If suddenly you see a spike of users doing the exact same thing and hogging your ports, then that is definitely a way to analyze. So what we do in cloud is we essentially give the ability to export all the logs into the centralized monitoring system and then perform analytics on the logs in real time. What you can do is identify the pattern in your application that is not normal, right? Any pattern that does not belong to your application, identify those patterns and then look for those patterns, right? Try a SLOWLORIES attack yourself and see how your application behaves, right? Employ a security specialist to perform vulnerability and breach penetration testing. That is the only real way to ensure that we are going to understand when a SLOWLORIES attack is coming in, right? Knowing your application. That is crucial. Knowing what your users do. If suddenly there are a huge number of escalations to assume privileges of a super user, of a root or administrator, then that is not a normal operation, right? That can be triggered as an alarm. If there are suddenly if there's suddenly an increase of long running operations, slow SYN packets, slow packets to the request, etc., then of course we need to do that through monitoring, through alerting, and alert the appropriate service or the appropriate group of people who will handle that. All right, so how do we secure? First thing, security of account. Make sure you got two-factor, multi-factor authentication in your account. That goes also for your access to your applications, two-factor. If you can implement it, always implement it. Google found that when they gave their 85,000 employees a little hardware key that cost $30, right? They essentially stopped all phishing attacks, right? With a little hardware key that cost $30, right? They used to have 100,000 phishing attempts every month, and they had a very low success rate of about 0.7% or something like that. But that's still a huge amount of phishing successes, right? As soon as they added two-factor authentication, first thing that happened was no breaches happened, no phishing, no phishing was successful. And then essentially the number of phishing attacks went down because the attackers gave up. They were like, yeah, we got the password, but there's two-factor authentication, There are smart ways to beat two-factor authentication also. I just was listening to a story on the radio a few days ago of a security specialist, an IT security specialist that was called up by their bank from their bank's phone number, was warned that there is a unknown charge from Florida. The attacker was in Canada. there was a charge from Florida, and they were asking whether he made that charge, and that charge is on standby right now, so they just need to verify his account number, right? So they asked him for the account number, and they asked him to essentially give them his other information, right? He was reluctant to give them too much information, but then they did a really nice trick. They said, all right, what we're going to do is we're going to send you a code for your two-factor authentication, and then you're going to read out that code to us so we can verify it's you. Now, the person was like, okay, that sounds legitimate, right? But what he didn't know was that his bank was actually using the two-factor authentication as part of the password reset process. So as soon as they got enough information about this user to get into that interface to try to request a new password, they chose the two-factor authentication. They sent the number to him. He read it out on the phone, right? And then they went into his account and said, okay, we see you have a purchase from here and there. Is that valid? And then you have a purchase from here and there. Is that valid? And he was confirming, yeah, that was me, except the one in Florida. That was all me. And they're like, okay, now we need your PIN, right? So they went a little too far, but he's a security specialist, and he shouldn't have even let them get that far. So as soon as they were asking for his PIN, he was like, okay, no, you don't share a PIN. Bye, I'm going to call you back. Now, what he should have done is he should have said, okay, thank you. I'm going to call you back on the number that's written on my card. And that's what everybody should always do if they get a call from their bank. If you get a call from the CRA, if you get a call from the IRS, always say, okay, I will call you back. Who do I ask for? Right? That is as simple as it is, right? So essentially what he did was immediately went, changed his password, secured his account. He was fine. But there are people who are going to fall for that. You know, it's your bank. They sent you the code to your mobile. Seems very, very legit. So again, even though you're using two-factor, always make sure you have educated your people. Next, encrypt your data. In transit, you can use HTTPS, you can use TLS. Databases have built-in encryption that will encrypt data in transit, like TD for Microsoft SQL or for Oracle. A lot of provider services will only work on a TLS connection on HTTPS, etc. You can also encrypt your data at rest, so make sure you have an encryption environment that's easy to use for your users, but is hard to break in for any attackers. Secure your access to the applications. As I said, secure the credentials, secure the multi-factor authentication, secure the operating system, put firewalls in, put IPS, IDS devices, put any kind of device that will allow you to get a better idea of what's happening. Stream out your logs, right? Push the logs out to a system that will be able to analyze logs and read those logs and make sense of them and look for patterns and inform you of an attack, inform you of something not normal, right? Protect from DDoS. Of course, put in implementations for DDoS protection, and of course, protect from injections or exploits with your firewalls, with web application firewalls, with features like that, right? Those will help you essentially build patterns that are allowed. If you just work on allowed patterns, then you're mitigating both injections and exploits possibly at the same time. You should also be layering security, right? Make sure you've got multiple layers of security. So what we want to do is we want to build an onion, right? An onion that has multiple layers. The more the attacker peels the onion, the more they will cry, right? And we want them to give up. We want them to give up at a certain point before they come to our server. And if they've come to our server, if their traffic looks super legit, then always monitor the response of the server to see whether that response does have any confidential data, whether that response is somehow being exploited. So be proactive, right? Monitor access to your account, monitor access to your applications, monitor access to the operating system, and monitor access to the platform. Right now, modern systems can all stream out logs line by line into collection systems, and those collection systems can continuously be audited by automated systems to check for any kind of issues. Also monitor performance, right? See if your performance metrics indicate an attack. Do you have a high number of TCP ports open and low number of CPU usage? That's a clear indicator of a SLOWLORIES attack, right? If your application is not performing well and you look at your performance graphs and you say, I don't see that as a normal pattern, then you're half the way there to figuring it out, right? Also periodically capture state. Within cloud, what we can do is we can look at our objects, we can look at the state of the objects, capture that state, and that state can be used to compare whenever some kind of attack happens to what was destroyed, what was lost, and we can also restore objects by restoring a certain previous state. Always use alerts on your monitoring, on your access, and on your state. All monitoring performance, all access performance and state monitoring tools will allow you to add alerts and allow you to respond to those alerts. And then, of course, you want to automate responses by making sure that any kind of response, any kind of entry from the log can be responded to automatically, right? So basic way is if somebody assumes an administrative privilege, right? Once they get that privilege, check a table of entries, whether that user is allowed to assume that privilege or whether he or she is scheduled to use that privilege. If not, then have an automated response that continuously checks and would immediately block that access, remove those credentials, kill that session. And then, of course, patch, verify, respond. Use patching with the same security lifecycle as you do for your security. Check what needs to be done, implement, verify, and then monitor, right? If you still see issues, then, of course, feed that information back into your selection of control tools. And, of course, automate updating, automate patching as much as you can. Use either config management or replace your machines with newer images that have been patched. So basically the question is in cloud, whether we want to patch or we want to replace. In cloud, what we want to do is we want to run stateless servers and store data in services. That means that our servers are just responding to requests. But when they retrieve data, they will go to a certain highly available backend, highly available data store, highly available file service, highly available object store. So do we want to patch those stateless services or do we want to just replace them? That's a good question, right? When your bike tire goes flat, what do? Do you patch the inner tube or do you replace it, right? The question is cost and, of course, speed. Are you going to be able to patch as fast as you can replace? Probably not. It's probably going to take some time to figure out where the hole is, you know, get your patching material and then patch it. The cost is also the question. Is patching cheaper than replacing, right? Sometimes it is. Sometimes it's not. Sometimes the glue doesn't hold well, so your tire goes flat again and you haven't done anything that you wanted to do. So when we are automating deployment, we need to choose how to use our operating system images for our applications, right? We can go for fully baked images. Now, fully baked images have everything in them. They've got the operating system, the security, the monitoring, logging, the application frameworks, and the application and the user data sometimes, and of course, all the latest patches. But if you're going with a fully baked AMI, then you're going to be a fully baked image. You're going to be replacing that image over and over and over again very frequently. You can then also do a completely dynamic at launch where you install and update every time you launch an instance. But then, of course, if you want to essentially update that instance, you will need to put some configuration management on top. And that can be very flexible, but also very expensive. And then you've got the ability to sort of have some flexibility, a flexible hybrid image where some stuff is pre-baked and then some stuff is launched during the application deployment, right? We should also look at DevOps, right? In DevOps, we should also be looking at security, right? DevOps basically follows a similar life cycle than the security life cycle. So why not implement security into DevOps? Cloud is always very much tied to DevOps. And if you are doing DevOps in the cloud, look at what you're doing, right? When you're planning the application, look at the security. Add the security lifecycle as part of the plan, right? Make sure you got a good plan for security for testing, right? When you code, make sure you got unit testing. Make sure you got checking of your code, static code reviews and things like that, right? Then, of course, when you build the application, check the application once it's built before you put it into testing for security. Then once it is in testing, you can do very, very like complex testing environments and do vulnerability scanning, do penetration testing once your application is in that phase. And of course, when it is in the release phase, again, penetration testing, vulnerability scanning, and then finally getting it to the acceptance phase. Only then will you deploy. And once you do deploy, continuously monitor and feedback any security findings into the plan. All right. So what did we learn? We need to secure all our access points. We need to secure our policy. Always use only the required privileges in your policies and in your firewall controls. Always implement a layered approach. Build that onion. Have the attacker peel it as much as possible and have them give up from crying too much. Implement IPS, IDS, implement firewalls in your operating system. Implement deep packet inspection if required. Always implement response monitoring, right? So, and essentially monitoring that can feed data into responses. Then look at performance logs, performance access logs so that you have an idea of what's happening. And then automate updates and automate responses to any kind of issues from the response monitoring, from the performance monitoring, and from log access. Those are the basics. Questions? We've answered some questions. So again, I'm going to thank Gerald and Ricardo for your very interesting questions. But if there are any questions, I'd like to give you a chance to ask them. And if there are no questions, then again, I'm going to thank you for joining this webinar. It was my pleasure to present this content to you. I hope you got a basic idea of what security is all about. Essentially, if you are interested in learning more about security, I should point you to the Web8 Solutions website. I'm just opening that. So if you go to web8solutions.com and you just look for security, you got a bunch of different security courses that we run, right? So essentially, we got a general cloud security training program overview here, right? So essentially, it's a security workshop. Then we've got IBM specific. We got cybersecurity and forensics. We got CompTIA security if you want to get certified. We got SOA for security professionals. We got the Microsoft Azure security. We've got security and SCADAs, financial banking security. We got AWS security, and we got all kinds of stuff. So if you are interested, here's the phone numbers. So again, webhsolutions.com. Let me just paste those phone numbers into the chat. If anybody is interested in talking to any of our salespeople, go ahead and dial those numbers. All right, web8solutions.com. And here's the phone numbers. The link to the slides is right here. So I'm going to resend the link to the slides. There we go. The presentation is available right there. And in a few days, you're going to get an email for our videos, right? So we got free webinars here. And if we go to webinars, this is today. And then we got past webinars. And in past webinars, you can search for the stuff that interests you. So for example, if you want to look at data warehousing, right? Then you got a webinar here. That's a bit old one. Let's see, we got any AWS webinars here? We don't. Okay, let's see DevOps. I know stuff always happens on DevOps. ITIL 4, great consideration. That's pretty new, right? That's for May. DevOps on AWS. Oh, that's me also. Yeah, very good. Then we've got DevOps using Azure. Plenty of stuff here, right? Plenty of cool webinars, architecture webinars. Also March, February, right? So very, very different ranges of knowledge here. And if you're interested in any of those, do give us a call. All right, since there are no more questions, I'm going to thank you for attending, and I'm going to end this session. So yeah, if you have anything else, please get in touch with our teams. Goodbye.